All right, today we'll be looking at quadratic theory and more specifically focusing on the discriminant part. So let me cover through some theory first of all. Remember, b squared minus 4ac is our discriminant taken from the quadratic formula. Right, so usually we look at the value of the discriminant here to tell us whether there are real roots in the equation. All right, so when b squared minus 4ac is greater than 0, usually there are two real and distinct roots. So we will see this phrase come up in the in the questions. When they tell us that there's two real and distinct roots, we know that b squared minus 4ac be greater than 0. b squared minus 4ac equals to 0 is when there's one real root, or in the question, sometimes it's stated is tangent to the curve, or maybe touches the x-axis once. So that's when b squared minus 4ac equals to 0. And finally, we have the last value, which is b squared minus 4ac is lesser than 0. This is when there's always positive or always negative or does not touch the curve. So these are the important details of the discriminant value which we must remember. And once again, we get these values from the equation ax squared plus bx plus c, which is your quadratic equation. So now let's move on to question 4 here, which tells us the equation of the curve given by x squared plus 2y squared equals 8 and y equals to 2x minus p is a straight line, blah, 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 blah. Find the values of p, which the line cuts the curve at two distinct points. So cut at two distinct points, we must recall b squared minus 4ac is greater than 0. But how do we get the equation ax squared plus bx plus c? Well, we want to substitute the value of y in, since they tell us that it's a straight line cutting the curve. So we take this in by doing this. Substitute y as 2x minus p. So we do our expansion here. And we can get our final quadratic equation as this. All right, so knowing this, we must remember that our b squared minus 4ac is greater than 0. So we substitute in our values. B is minus 8p, minus 4a, which is 9, and c, which is 2p squared minus 8, is greater than 0. So we have 64p squared minus 36 times 2p squared minus 8 greater than 0. 64p squared minus 72p squared plus 288 is greater than 0. We have minus 8p squared is greater than minus 288. So p squared is less than, because it's inequality, we flip the sign, is less than 36. So we have p squared minus 36 lesser than 0, p plus 6, p minus 6 lesser than 0. So once again, we want to recall the behavior of a quadratic curve. If we have a curve at an intersection at minus 6 and 6, they're telling us that it's less than 0. So we want the part that's below. So p would be between 6 and minus 6. So that's the answer for part A, which is worth 4 marks. Moving on to part B now. Find the ranges of value of k for which 3x squared plus k minus 2x greater than 2 minus k for all real values of x. Okay, so let's first look at the inequality. As we do, we want to move everything over to the left-hand side, so we have something is greater than 0. So we have 3x squared plus k minus 2x minus 2 plus k is greater than 0. So if it's greater than 0, it means it's always positive. Now, if we recall, always positives mean b squared minus 4ac is lesser than 0, because that's how it behaves if we look at the discriminant here. So moving back to the equation, we can continue by substituting in our values. K minus 2 squared minus 4a times k minus 2. I've rearranged it to k minus 2 in this case. Is lesser than 0. So we have k squared minus 4k plus 2 minus 12k plus 24 is lesser than 0. We have k squared minus 16k plus 28 is lesser than 0. So we factorize this to get k minus 14 and k minus 2 is lesser than 0. So once again, we look back at our behavior of our quadratic curve. If the solutions are 2 and 14 and they want lesser than, we have to highlight this part. And that's the area we want, which is between K2 and 14. This is our final answer. It's 3 marks. So once again, we're seeing how we must read the question very carefully to see what kind of inequality we want to use. So example, in this case, for question A, we want to use b squared minus 4ac is greater than 0 because it cuts at 2 distinct points. Well, here we want to use b squared minus 4ac is lesser than 0 because we have an always positive value. So we must see how the math is presented or how the question is presented and use the discriminant value accordingly. All right, moving on to question 11. They tell us, given that fx equals to k plus 2 blah, 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 is always positive. Find the value of fx is always positive. Okay, so knowing this, we can substitute in our values. Fx, in this case, we can let it to be y is equal to k plus 2 x squared minus 12x plus 2k minus 1. Always positive, which means that the value is always, hold on, let me write it down again, greater than 0, which means b squared minus 4ac is lesser than 0. So once again, we see this kind of word come up, always positive. We immediately link it to our discriminant. So we substitute in our values, minus 12 squared minus 4k plus 2, 2k minus 1, 2k minus 2 because we want to expand that. Okay, is lesser than 0. We have 144 minus 4 times, we expand this whole thing, 2k squared minus 2k plus 4k minus 4 less than 0. 144 minus 4 times 2k squared plus 2k minus 4 less than 0. 144 minus 8k squared minus 8k plus 16 less than 0. Then we want to divide everything by a negative sign. So we flip the inequality to get 8k squared plus 8k. 144 plus 16, that is 160 minus 160. Divide everything throughout by 8, we get k squared plus k minus 20 is greater than 0, which we can factorize to k minus 4, and k plus 5 is greater than 0. So we look at our curve, we have an intersection point of 4 and minus 5, and they want the value that is greater than 0. So we have this part and this part. So k is lesser than minus 5 or k is greater than 4. However, it is important to note that we do want it to always be positive, which means we always want it to be greater than 0, which means there's an added thing we have to look at, which is this value here. This k plus 2 value here. Now, if we recall, the ax squared plus bx plus c, the a here will determine whether it's a happy face curve or a sad face curve. Now, if we want fx to always be positive, we would usually want it to be a happy face curve because an unhappy face curve would always be either negative and a happy face curve will always be positive if it never touches the x-axis. Because imagine, can an unhappy curve be positive with without touching the x-axis? It simply can't. If you look at the graphs, look at it graphical solution-wise, if you want it to always be positive, it will always have to pass through the x-axis, which means that there'll be parts that's negative and positive, so it won't fulfill the requirement. Therefore, our value of a, in this case, k plus 2, must be greater than 0. As such, if k equals to minus 5, our value of a here, k plus 2, will be minus 5 plus 2 minus 3, which means we get an unhappy curve. If we get the unhappy curve, it does not fulfill the requirement of fx being positive. So once again, to summarize the point, if it tells us that fx is always positive, we want it to be a happy curve, because if it's a sad curve, it will never be positive because it's all negative values. Similarly, if it tells us fx is always negative, then we want it to be a sad face curve because it will never go above the x-axis into the positive y section. So this is positive y, this is negative y. So therefore, we have to reject this k minus 5 value here. And therefore, we can only accept k greater than 4 as our answer. All right, so I'll leave part B for y'all to do, as well as the other questions. And here, we must remember that at 2 distinct points, we want b squared minus 4ac to be greater than 0. Then we look on at question 12, in which they tell us various things. Question 7a here is a simple and straightforward question you can solve by dividing the inequalities onto both sides. And here, we must look at the always positive, which they tell us mathematically. So b squared minus 4ac is always lesser than 0. Thank you so much and have a good session.